8.3 Geometric sequence and series. What you should learn. Recognize, write, and find the nth term of a geometric sequence. Find the nth partial sums of a geometric sequence. Find the sums of an infinite sequence. And use geometric sequence in real life problems. So geometric sequence is the multiplication version of arithmetic sequence. So for example, if I have 2, 6, 18, 54, ... all these terms are being multiplied by 3. So it's like an arithmetic sequence, but instead of being added every single time, you're multiplying or dividing every single time. And the thing you're multiplying by, we call that a common ratio. Easiest way to find it is put the second term over the first term to get your common ratio. Or in general, put a term over the one right before it. That gets your common ratio. So it's much like an arithmetic sequence, just the multiplication version of it. So here's some examples, right? 2, 4, 8, 16 multiplied by 2. So there's my geometric sequence. 12, 36, 108. They're multiplying each term by 3. Over here, they're doing a fraction, and it's a negative fraction. They're multiplying by negative 1/3 every single time. So you see the sign change. So that could happen in geometric. The sign could change every single time because you can multiply by negative. And then again, if you have something that's like a squared term, that's not geometric. So here's our basic formula for a geometric sequence. AN equals A1 times R to the n minus 1. So A1 again is the first term. We have no D, but we have an R. R is a common ratio. And remember, the way we find that, easiest way to find R is A2 over A1. And then N is the nth term. Or N is the term number. Sorry. AN is the nth term. So that's the formula. It's a little more basic formula. So for example, write the first 5 terms of a geometric sequence whose first term is A1, whose common ratio is 3. So let's do a couple things. Let's write the formula first. So AN equals A1 times R to the n minus 1. So first I want to write the formula. A1 is 3. 3 times my R is 2. N minus 1. There we go. Now I could just substitute 1, 2, 3, 4, 5 into this formula to get my first 5 terms. But honestly, just like when we do arithmetic sequence, if you know what the common ratio is, all you have to do is multiply by your common ratio. So times this by 2, so you get 6. Times that by 2 to get the next one. We're going to get 12. A4 would be 24. And A5 would be 48. Right? Anytime you have the common ratio, you know what the first term is in the common ratio, it's very easy to go up and down the first few terms. Next one, find the 15th term of a geometric sequence whose first term is 20, whose common ratio is 1.05. Okay, so anytime you're missing something, let's go back to the general formula. A1 times R to the n minus 1. And what do we have? We want the 15th term, so this will be 15. 15. First term is 20, so that's A1. And the common ratio is 105. So this is 1.05. So A15 is going to be 20 times 1.05 times 15 minus 1. So all this is substitute into our calculator. And we get 39.598631999. Let's approximate to 39.6. So that's the 15th term of the sequence. Find the geometric sequence. Find the formula for an nth term of a following geometric sequence. What is the nth term of a sequence? So again, they want a formula again. Well, I guess they want one last time. I just provided one. So they want a formula. So we're going to have this. All we need is A1 and R. All you need to find the formula. Well, first term is 5. R, remember, the easiest way to find R is to put the second term over the first term. If you want, you can put the third term over the second term. That also works. Sometimes it's easier to do it that way. But either way, you should always do the same thing, 3. So that's my R. So AN equals 5 times 3 to the n minus 1. That's my formula. And now they want the 9th term of the sequence. Well, that's so much easier when you have the formula. AN is equal to 5 times 3 to the n minus 1, which is just 5 times 3 to the 8th. I don't know that by heart. So substitute in your calculator and you get 32805. So 32,805. Now, when you know any two terms of a geometric sequence, you can use it to find the general formula. This kind we did the same thing with arithmetic, but now we're going to do it geometric. So let's try with this one. The fourth term of a geometric sequence is 125. So remember, our basic formula is an equals a1 times r to the n minus 1. So all we're going to do is plug in this into that formula to make an equation. So the fourth term, when I plug in 4 for n, I get 125. All right, so this is just saying a4 equals 125. So if we type that into here, 125 is going to equal a1 times r to the 4 minus 1, also known as 125, equals a1 r cubed. That's right, when I substitute in 4, I get 125. So that's our one equation. Our next equation, the 10th term is 125 over 64. So now, same idea, when I substitute in 10, I get 125 over 64. So a10 equals 125 over 64. So when I 125 over 64 equals a1 times r to the 10 minus 1, or 125 over 64 equals a1 times r to the 9th. So we have two equations to unknowns. We cannot do elimination. We have to do substitution, right? So the general rule is get the smaller power and solve for a1 there, right? So we have r9 and r3. You want to solve for the smaller one first. That's the trick. So here we're going to have a1 equals 125 over r cubed, right? So I got a1 by itself, and now we're going to substitute that into the a1 here. So we'll plug it into this one there. So I'm going to have 125 over 64 equals 125 over r cubed times r to the 9th. Right, so I'm plugging into this formula here, but a1 I'm substituting that for. Well, the first thing that happens, this is over 1, so these reduce, that's a 6. So we get 125 over 64 equals 125 r to the 6. Let's get rid of that 125 and multiply both sides by the reciprocal 125. So those cancel and I get 1 over 64 equals r to the 6. Let's take the 6 root of both sides. And then you get r equals 2. So now we know r equals 2, we could plug it back into here to figure out what a1 is. a1 is going to be 125 over 2 cubed, so 125 over 8. So that's our formula. Let's rewrite it. I know I'm kind of all over this, I'm sorry. But we know what a1 is, we know what r is, we can write the formula. So a1 is 125 over 8 times 2 to the n minus 1. And now I think there's one more question, which was find the 14th term. So let's plug in 14. So 125 over 8 times 2 to the 14 minus 1. And much like before, I'll plug this into our calculator. In this case, I'll do it on camera. So we have 125 divided by 8 times 2 to the 13th power. And we need 128,000. That's the 14th term. So there you go. Right, so same idea as calculating arithmetic, right? You have to make up two equations to unknowns. In this case, you have to solve by substitution. So make sure to do whatever the smaller one is, the smaller power you have, solve for that one. So make a1 part of that. And once you solve your equation for the first variable, plug it back in to find the second variable, and then you can rewrite the equation and find any term you want. Okay, let's talk about the sum of a finite geometric sequence, right? So the finite one. So this is a sequence that ends. So we have a formula that we're going to use right here. So when you see this, we're going to equate it to this. This is our sum of a geometric sequence. So first of all, notice that it's a geometric sequence, right? We have an a1 and an r to the n, right? So our first term is right there, and then there's our r right next to it. So when I see that, I know it's a geometric sequence, and I can use this formula. What is our n? N is the top number there. So let's do a couple examples. So this first one, first thing I noticed, it is a geometric sequence because it's in this setting. So it's geometric, and this is my a1 is right here. My r is right there because that's the one that has the power, and this is my n. So when we use the formula, a1 1 minus r to the n over 1 minus r, which is the sum of geometric sum, all we're going to do is plug everything in. So I'm going to have 4 times 1 minus 0.3 to the 12th all over 1 minus 0.3. Now again, let's bring up the calculator so I can show you how I would do this on the calculator. So I would use alpha y equals to bring this up, and then we can use a fraction. Makes it so much easier. 1 minus 0.3 to the 12th on the side there, then on the bottom 1 minus 0.3. We get 5.7914. If we don't want fractions, then we go back to math and go fraction. Let's just say if we don't want decimals, we go back there. This is an irrational number, so we're going to keep the decimal, 0.571428. We'll round it to 5.7. 5.71. Okay, so that's how you find the sum of a geometric sequence. So if we're talking about geometric series, remember series when you're adding every single term. There's two types. There's finite and infinite. Now when we already did the finite one, so if there's an infinite one, it's actually a different formula. It's actually a lot more basic formula, but this only works when two things happen. First, r has to be less than or equal to 1. Absolute value of r has to be less than or equal to 1. And also has to go to infinity. Right? So it's an infinite sum. So it only works when r is less than 1, because that means it's getting smaller. You could find the infinite sum. If r is getting bigger, you can't find it. This is growing. If it's doing this, if it's growing, can't find. Because it's getting too big. It's going to be infinity. But if it's getting smaller, that means it's getting closer and closer to 0, and you can find the infinite sum. So a couple of things, right? This is a formula. Very simple. A1 over 1 minus r. It only works when two things are true. When it has to go to infinity, and your r, thing to the power, is less than 1. So let's do a couple examples here. So I see that, so I'm like infinite sum. S infinity is a1 over 1 minus r. My r is right there, and r is less than 1. So that holds true also. So we're just going to do the formula. So 4 over 1 minus 0.6. You can put in your calculator really. So do by hand real quick. So I get 0.4, which is, let's move over the decimal. So if I move over the decimal, I gotta move the decimal here. So 40 over 4, which is 10. Alright, so all I did was 1 minus 0.6 is 0.4. Well, I want to cancel these out, but this has a decimal, so you move it over 1. If you move it over 1, you move it over 1 there also. So 40 over 4 is 10. The next one, we've seen this before, right? My A1 is right there. What is my R? They're getting divided by 10 every single time. So 1 over 10 is my R. So I could find the infinite sum. We actually did this earlier, right? So I'm going to do A1 over 1 minus R. And so that's going to be 3 over 1 minus 1 over 10. Same idea. I'm going to try to do it by hand real quick. 3 over 9 over 10. So that's the same thing as saying 3 divided by 9 over 10, which is 3 times the reciprocal. And I get, reduce, I get 10 over 3. Is the sum of that. So if you add this, plus that, plus this, all the way to infinity, you get 10 over 3. And that's the lesson.